Hey everyone. Hope you had a fantastic Thanksgiving break and some time off of school and that you're ready to go. We just have so few class periods before the end of the semester, which is crazy. So today you're going to watch this video that's going to be some examples more using the product and the quotient rules. So no new rules today, but just some more advanced examples. And then on Thursday, you're going to have just another worksheet on practicing with the product and quotient rules. So you should be really good on those by the time I see you again next Monday. Before we get started with the examples, though, and I hope that this is readable, we're going to see as I swivel around here. Just a few things to remember that are going to be useful for us so that we don't have to do them every time. I've mentioned this a couple of times. This is a really important rule that we see quite often where we need to take the derivative of the square root of x, and that is going to end up being 1 over 2 square roots of x. Again, you can change that to x to the 1/2 power and use the power rule there. So you can pause and try that out if you don't believe me. Also, just recalling that the square root of x is the same as writing x to the 1/2 power. That's going to come up here in just a little bit. And then also, when you multiply bases, so x, like for instance, x to the first times x to the 1/2 power, that is readable, that you would get actually x to the 3/2 power. In that case, we are adding the exponents, so 1 plus 1/2 is 1.5, or we would call that x to the 3/2 power. And then the other thing, just again to recall, that the product rule says that we want the first times the derivative of the second plus the second times the derivative of the first. In another form of notation, we have f of x times g prime of x. Remember that g prime would be the derivative of g. And then we have g of x times f prime, because f prime, again, is the derivative of f of x. So just a little bit more concise notation there. And then lastly, the quotient rule, which would be, okay, so our quotient rule, again, I don't know where I was. I had to pause for a minute. Sorry, guys. Is low times the derivative of the high, which would be f prime of x, minus high derivative of low, which is g prime of x, all over low squared. Okay, so let's look at our first example. We're going to find the derivative. And this one is f of x equals x plus 2 times 2 square roots of x minus 5 all over x minus 2. So this is a case where, there we go, where we have a quotient rule, because we do have a quotient. Inside the quotient rule, though, on the top we have a product. So we have a product rule inside of a quotient rule. And I'm going to start by writing what we would do for the quotient rule, and then we'll kind of see how that goes. So we're going to have low, which is x minus 2, times the derivative of high, minus high, times the derivative of the low, all over low squared. Okay. Now, when we, guys, I hope you can see that. I'm going to try to scooch it a little closer. Okay, see if that works. When we work with this, then, we'll have x minus 2. Now, the derivative of this is a product rule. So I'm going to leave that in brackets, and I'm going to have first, which is x plus 2, times the derivative, so I'm going to write d dx, of 2 square roots of x minus 5. So that's first d last, plus last 2 square roots of x minus 5, d first, x plus 2, and that's all in brackets. So this is still just low, d high, okay? Minus, we still have to write this stuff. So we'll have minus x plus 2 times 2 square roots of x minus 5 times the derivative of x minus 2. The derivative of x minus 2, though, is 1. All over x minus 2 squared. Then next, we'll go ahead and take these couple of derivatives that we have left over on the top. This is where, again, your notation is so very important to keep things organized, or you can get lost really quickly. So be very, very careful here. So up here, I'm going to leave this still, again, in brackets. We're going to have x plus 2. Now, I need the derivative of 2 square roots of x. The derivative of just the square root of x is 1 over 2 square roots of x. So this would be 2 over 2 square roots of x, or 1 over the square root of x. And then the derivative of 5 is 0. So this whole derivative is just 1 over the square root of x. Then we'll have plus 2 square roots of x minus 5 times the derivative of x plus 2. The derivative of x is 1. The derivative of 2 is 0, so that's just 1. So that turns out not quite so bad. Minus, now eventually, let's just leave it like this for now. 1 times all of this is just going to stay as this. And that's all over x minus 2 squared. Do you have to write this every time? The answer is yes. You do need to write it every time. All right. Next, we'll have x minus 2. Now, in this bracket, I'm going to recognize that this is really x plus 2 times x to the 1/2, negative 1/2 power. Okay. I can rewrite the square root of x as x to the 1/2. When I move it, then it's negative 1/2 power. And then I'll have plus, this is now, I'm going to rewrite this as 2x to the positive 1/2 power minus 5 times 1 is still just that. Minus, I'm going to go ahead and rewrite this using the exponent instead. So 2x to the 1/2 minus 5. Now, in order to simplify this, we're going to need to, the rest of this whole problem is, and I'm not trying to poo-poo it because it is a lot to deal with, but it really just is some algebraic manipulation. So we're going to be multiplying and combining like terms as we go. So I'm going to have x minus 2. When I multiply in here, I'm going to distribute this. X times x to the negative 1/2 is x to the positive 1/2, 1 plus negative 1/2. And then 2 times x to the negative 1/2 is just 2x to the negative 1/2. And then really this is plus this set of parentheses, which is just that itself. Okay. When I multiply these two together, I have to actually do some distributing. So I'm going to start with x times 2x to the 1/2, which will be 2x to the 3/2, right? X times x to the 1/2 we talked about. X times negative 5 is negative 5x. 2 times 2x to the 1/2 is 4x to the 1/2. And 2 times negative 5 is negative 10. All right, slide that down a bit. Okay, now we've got to, we can combine a little bit of like terms in here. So I have x minus 2 times now 3x to the 1/2 plus 2x to the negative 1/2 minus 5. I'll go ahead and distribute this negative sign, so I'll have minus 2x to the 3 halves plus 5x minus 4x to the 1 half and plus 10. Then we'll distribute in here. It's going to be quite lengthy. See if we can fit it all in here. So I'm going to do x times each of these terms. So x times 3x to the 1 half is 3x to the 3 halves. X times 2x to the negative 1 half is 2x to the positive 1 half. And x times negative 5 is negative 5x. Then we need to take negative 2 times each of these. So we'll have negative 2 times 3x to the 1 half, which is negative 6x to the 1 half. Negative 2 times 2x to the negative 1 half is negative 4x to the negative 1 half. And negative 2 times negative 5 is positive 10. Then we still have these 4 terms. None of them are like terms yet, so we will rewrite those. All still over x minus 2 squared. Okay. And I think, luckily, since we're at the bottom of the paper, we're about to find our final answer. Now I'm going to be looking for any like terms I have that I can put together. We have 3x to the 3 halves minus 2x to the 3 halves, which would be 1x to the 3 halves. I'm going to go ahead and just kind of mark those out because they're done. Next, I have 2x to the 1 half. I have negative 6x to the 1 half, and I have negative 4x to the 1 half. So I have 2 minus 6, which is negative 4, and negative 4 minus 4 is negative 8. X to the 1 half. And again, I'm going to go ahead and kind of mark those out because I'm done dealing with them. Then I have, negative 5x plus 5x. Those cancel each other, so that's nice. I've got 10 plus 10. 10 plus 10, which is 20. So I've got that. And then the last thing I have is this negative 4x to the negative 1 half. And that is all over x minus 2 squared. And that will be our final answer for this problem, where we had to use a product rule inside of a quotient rule. Okay, now we're going to do a problem. The second one we're going to do is this one, x to the negative 3rd times x squared plus 1 times 3 minus 4x times 4x to the 5th plus 2. And this one is kind of interesting because we actually have the product of 4 different factors. And in doing that, we don't have a product rule that says what to do with 4 factors. So what we really end up doing is sort of grouping them together. And the way I'm going to group it, and probably the easiest way, is to think of these 2 factors together, the first 2, and then these 2 factors together, so that we have the product of really now 2 things. So this will be first, and this will be our last. So when we think about that product rule. Now, what's going to end up happening then is we're going to have a product rule inside of a product rule. And I'm going to try very carefully, without destroying things, move this forward a little. Let me see if I can get this to be a little bit bigger for you guys. That might be a little better. Okay, let's go with that. So on this one, because we're doing a simple product rule first, we'll have first, which will be x to the negative 3rd times x squared plus 1 times the derivative of the last, which is 3 minus 4x times 4x to the 5th plus 2, plus last 3 minus 4x, 4x to the 5th plus 2, times the derivative of the first, which is x to the negative third times x squared plus 1. Okay. Now, the derivative of the last, here at the beginning, is going to be another product rule. So this is a product rule inside of a product rule. And I'm just going to warn you, this gets rather lengthy going across, so I'm going to do the best I can to fit it all on one line, or I don't know, we'll do the best we can. Might be a little small, you might have to zoom in a little. So I'll write x to the negative third times x squared plus 1. Now this derivative, I'm going to leave in brackets, is going to be first 3 minus 4x times the derivative of 4x to the fifth plus 2, which I'm going to rewrite now as 20x to the fourth, right, plus 0. Hopefully everyone's okay there. The derivative of this is 20x to the fourth plus the last 4x to the fifth plus 2 times the derivative of 3 minus 4x. Well, the derivative of 3 is 0. The derivative of negative 4x is negative 4. And that's that. Plus, now I've got this set, 3 minus 4x, 4x to the fifth plus 2. And then I've got this derivative, which again is going to be another product rule, which is first, x to the negative third, times the derivative of the last, the derivative of x squared plus 1 is 2x, plus last, x squared plus 1, times the derivative of the first. The derivative of x to the negative third is negative 3, x to the negative fourth. Okay. Now, we've actually done all of the derivative stuff that we need to do. The whole rest of this problem, again, is algebra. Again, it's not easy algebra necessarily, but it is just going to be a matter of keeping things sort of organized. And eventually, I'm going to want to have this entire expression expanded and simplified. So I'm going to do some multiplying as I go to kind of help out that process a little bit, so that we can then combine like terms in the end and end up with just a final polynomial type answer. So I'm going to start here. I'm going to go ahead and distribute this x to the negative third. X to the negative third times x squared. We would add those exponents together, which would give me x to the negative first. X to the negative third times 1 is just x to the negative third. That's going to be in parentheses still. Okay. Then we're going to, in here, in the bracket, I'm going to go ahead and distribute 20x to the fourth, so I'll get 60x to the fourth minus 80x to the fifth. I'll go ahead and distribute this negative 4, so I'm going to get negative 16x to the fifth minus 8. Okay. Then here, again, we can go ahead and multiply those out. So 3 times 4x to the fifth is 12x to the fifth. 3 times 2 is 6. Negative 4x times 4x to the fifth is negative 16x to the sixth. And negative 4x times 2 is negative 8x. Yes. And then inside this bracket, we'll also go ahead and multiply. This is going to give me 2x to the negative second. Again, adding those exponents, 1 plus negative 3 is negative 2. Here I'll distribute, so I'll have negative 3x to the negative second. Again, adding exponents. And I'll have negative 3x to the negative fourth. Okay. And before I go on, I'm going to go ahead and combine some like terms before I do any more multiplying. So x to the negative first, x to the negative third, that doesn't change. Inside of this set of brackets that I'm going to now make into parentheses, I've got a couple of like terms here. So I'll have 60x to the fourth minus 96x to the fifth minus 8. In this set of parentheses, I don't have anything I can do there to combine like terms. So I'll leave that 12x to the 5th plus 6. And yes, I know that's not necessarily in standard form, but I don't need to worry about that yet. And then over here, I've got a couple things. I've got 2x to the negative second minus 3x to the negative second, which will be negative 1x to the negative second. Okay. Now we're just going to be distributing. So here we're going to get 6 terms. Here we're going to get 8 terms. So we're going to have a total of 14 terms going across our paper, if that kind of gives you any clues to how much space you're going to need there to write those down. So we've got x to the negative first times 60x to the fourth is 60. X to the negative, or to the positive third. Sorry, negative 1 plus 4 is 3. X to the negative first times negative 96. X to the fifth is going to be negative 96. X to the fourth. And x to the negative first times negative 8 is negative 8. X to the negative first. Then we'll have x cubed times 60x to the fourth, which is going to be 60x to the first. X to the negative third times negative 96x to the fifth is negative 96x squared. And x to the negative third times negative 8 is negative 8x to the negative third. Okay. And I think we're doing okay on that so far. Let me slide this over. Turn it a little, maybe go like this. That might help. Okay. Then we've got to multiply here. So we're going to get negative 12x cubed minus 6x to the negative second plus 16x to the fourth and positive 8x to the negative first. Okay, that was negative x to the negative second times each of those terms. Now I'll do negative 3x to the negative fourth times all of these. That's going to give me negative 36x, negative 18x to the negative fourth, positive 48x to the second, and lastly, positive 24x to the negative third. Okay. Oh, yes, just squeezed it on there. Okay, then we're going to be now looking for like terms. Now, at this point, if I want to, and if I want to be kind of cautious about it, I can think about standard form. So I'm going to start with the highest power of x and work my way down. So we're going to start with x to the fourth power. I've got a couple of things. I've got negative 96x to the fourth plus 16x to the fourth. That's going to be negative 80x to the fourth. Again, I'm going to just cross those out now so I don't have to worry about them anymore. Then I'll look for the x cubes. I have 60x cubed. I have negative 12x cubed. And that's it. So 60x cubed minus 12x cubed is 48x cubed. I'll cross those out because I'm done with them. I'll look for the x squareds. Negative 96x squared plus 48x squared, which is negative 48x squared. I will cross those out. Then x to the first power. I have 60x to the first power. And I have negative 36x to the first power, which is 24x to the first power. 60 minus 36. I don't have any terms that do not have an x at all. So I'll move on. Then I'll look for x to the negative first. That would be the next highest power of x. Interestingly, I have negative 8x to the negative first plus 8x to the negative first. Those cancel to be 0. I'll look for anything x to the negative second. I have negative 6x to the negative second. That's the only term I have with that exponent. Then x to the negative third, we've got negative 8x to the negative third plus 24x to the negative third, which is 16x to the negative third. And lastly, we have one term, this minus 18x to the negative fourth. And that would be our final answer for this problem. Using the product rule inside of the product rule twice. Okay, now we're going to shift gears a little bit. Instead of doing products inside of quotients and products inside of products and all of those, where again, you just really need to keep your notation in order. We're going to look at a problem like this, where we have capital F of x is expressed in terms of little f of g of x and little f of x and g of x. We're going to find f prime of 4, given that f of 4 is negative 2, f prime of 4 is 8, g of 4 is 2, and g prime of 4 is negative 10. And the first problem says that big F of x is equal to f of x times g of x. And here's the thing that you have to remember. Sometimes when we're thinking in generic terms, the derivative f prime of x, capital F prime of x, is the first, and we wrote this kind of at the very beginning of the notes today, times the derivative of the second, plus the second times the derivative of the first. Okay, so we're thinking about that sort of in generic terms, even though we don't know what f of x and g of x are. Then if we want to find f prime of 4, we're going to put 4 in place of all of these x's. So now we really want f of 4 times g prime of 4 plus g of 4 times f prime of 4. Well, we know all of these values. F of 4 is negative 2. So this will be negative 2 times g prime of 4. G prime of 4 is negative 10. Plus g of 4, which is 2, times f prime of 4, which is 8. Or f prime of 4 is negative 2 times negative 10, which is positive 20, plus 2 times 8, which is 16, or f prime of 4 is 36. Okay, and again, that's pretty straightforward when you think about what we're doing, but we're having to think in those kind of generic terms. Okay, let's look at one more of these. I'm going to try to squeeze that on in over here on this side. This time let's have f of x, capital F of x, is g of x divided by 3 plus f of x. Okay. So this time we're going to need to use a quotient rule. Again, we're going to think about that quotient rule in very generic terms to begin with. So f prime of x is low, or 3 plus f of x, times the derivative of high, which is g prime of x, minus high, which will be g of x, times the derivative of 3 plus f of x. Well, the derivative of 3 plus f of x, the derivative of 3 is 0. The derivative of f of x is just f prime of x. So that will just be f prime of x all over 3 plus f of x squared. Okay. But now again, we're going to replace all of those x's with 4's because we want to know, we're interested in finding out f prime of 4. So we'll have 3 plus f of 4 times g prime of 4 minus g of 4 times f prime of 4 all over 3 plus f of 4 squared. Oh, hello. Okay, but again, we know all of those values. Let's see if I can leave those. There we go. That'll work. We'll have on top 3 plus f of 4. F of 4 is negative 2. So 3 plus negative 2 times g prime of 4. g prime of 4 is negative 10, minus g of 4 is 2, times f prime of 4, which is 8, over 3 plus f of 4, so again, 3 plus negative 2 squared, or f prime of 4 is 1 times negative 10, which is negative 10, minus 2 times 8, which is 16, over 1 squared, which is just 1, or f prime of 4 is negative 26. And I did fit that all on that one page. Okay. Okay, so that is some more advanced and different kinds of examples of problems that you're going to be doing on your assignment today. Let me write the assignment right here. Before Thanksgiving break, you were given, okay, if you're in 5th hour, okay, 5th hour, you were given a page. You're not going to do anything out of your textbook. This is on page 112 and 113. So you can either use the copy page that you already were given before Thanksgiving break. I left extra copies with these plans. And I also, you can find this on the online textbook. Okay, so there's 3 different ways you can find it. You're going to do 15 through 24 all, and 27 through 30 all. Okay, and that will be your assignment. If you're at 8th hour, you can use your textbook. You can get a copy of the pages if you would like to, or you can use the online textbook. That's your assignment for today. Now, for this particular one, what I want you to do is you're going to submit a photo of this assignment into Canvas by class time on Thursday. Then on Thursday at class time, the answers will be in Canvas, and you can look at those and kind of check your answers. Compare with some people around you. If you were not sure about how you got something, maybe try to help everyone around you to try to figure out what happened, and then you'll have another page to practice more product and quotient rules on Thursday. So that's the plan. So don't forget to submit a picture of your assignment in Canvas on Thursday, and I will see you next Monday. Have a great rest of the week. Bye.